Have you ever wondered what drives the silent, unseen movement of water deep beneath the Earth's surface? The hydraulic gradient is the fundamental force that governs groundwater flow, and it is calculated by determining the change in hydraulic head over a specific distance along the flow path. Understanding the hydraulic gradient is absolutely crucial because it tells us both the direction and the magnitude of groundwater movement. Imagine water always seeking the path of least resistance from a higher energy state to a lower one. In groundwater, this energy is represented by the hydraulic head. The greater the difference in hydraulic head over a given distance, the steeper the gradient, and the faster the groundwater will tend to flow. This principle is at the heart of Darcy's law, which describes the velocity of groundwater. To calculate this, you need two measurement points, typically monitoring wells. First, you measure the hydraulic head at each well. Hydraulic head is essentially the elevation to which water rises in a piezometer or well, plus the elevation of the well bottom relative to datum, like sea level. For simplicity, we often use the water level in the well as the hydraulic head, assuming the well is screened across the water table. Next, you measure the horizontal distance between these two wells. Finally, you subtract the lower hydraulic head from the higher hydraulic head, and then divide that difference by the horizontal distance between the wells. The result is a dimensionless ratio, though it's often expressed as feet per foot or meters per meter, representing the slope of the piezometric surface. This calculation isn't just an academic exercise, it is a powerful tool for hydrogeologists. By plotting multiple hydraulic head measurements, we can construct equipotential lines on a map, which are like contour lines for hydraulic head. Groundwater flows perpendicular to these lines, always moving from higher to lower head. This allows us to predict contaminant migration pathways and delineate capture zones for pumping wells, giving us an incredible insight into what is happening underground. By mastering the calculation of hydraulic gradient, you gain the ability to predict the invisible pathways of groundwater. This knowledge is indispensable for effective groundwater resource management, environmental protection, and sound engineering practices, ensuring we understand and responsibly interact with our planet's hidden water systems.
If you love learning about water, like, subscribe, and keep exploring with us.